The most widely used road paving material throughout the world, asphalt, has some unique and desirable characteristics. It's known as the flexible pavement because it has the ability to gradually change shape, to bend with minor shifting of the earth. During temperature changes, it can expand and contract without cracking. And when properly produced and installed, asphalt gives a riding surface that is extremely smooth, quiet, comfortable, and safe. Asphalt production facilities have made tremendous advancements in recent years, and CMI Corporation has been a driving force in this progress from the beginning. For 75 years, virtually all asphalt was produced in batch plants. In 1970, CMI and several other manufacturers began making hot drum mix plants. Within a short 10 years, the parallel fold drum mixer dominated new plant construction and sales. Today, there are more CMI hot drum mix plants in operation than any other brand. Before we look at the features of drum mixers, let's be sure we understand exactly how hot mix is produced. We'll use animation to show it more clearly. If a mix were made of large stone aggregate only, it would have large gaps between the stones. So smaller aggregates are mixed in to fill the gaps. There are still gaps, but now they're much smaller. So even smaller aggregate or sand is added until the mix is almost solid. All aggregates contain a certain amount of moisture, and this could vary from 1 or 2% to 10% or more. Inside the drum mixer, the aggregate and moisture are heated. When they reach the boiling point of 212 degrees Fahrenheit, the temperature holds steady until all the moisture is converted to steam. The vast majority of energy expelled by the burner is used up in this brief drying process. The aggregate, which is now completely dry, continues to be heated until it reaches the prescribed temperature, usually around 300 degrees. Then hot liquid asphalt is added and the mix is tumbled and blended together until all stones are thoroughly coated. Then the mix is finished and ready to lay down or to store till it's needed. All other components of an asphalt plant exist solely to support this process. Research at CMI has brought about some major innovations in drum mixer designs. We started by making the drum longer. In 1976, we introduced mid-drum entry of recycled material. In 1981, we introduced the expanded combustion zone and were instrumental in development of the Starjet burner with its short, wide flame pattern and quick heat release. The following year, we expanded the discharge end of the drum to complete the now familiar Venturi mixer shape. Since that time, the drum has been made even longer, and the discharge end has been expanded even further. All the time the outside shape of the drum was undergoing an evolution, the inside was keeping pace. Flighting was made interchangeable, and a variety of sizes and shapes were used to control the flow rate in each section independently. Today's Venturi mixer drum is the culmination of 25 years of research and technological advancement. The expanded combustion zone gives the burner plenty of room, so there's no carry-through of unburned fuel. Flighting in this area is designed to capture the aggregate as it enters and hold it close to the shell through most of the revolution, veiling only down the sides and not through the flame. Since the aggregate is cool at this point, it rapidly absorbs heat from the burner, insulating and protecting the shell. The center section is reduced diameter for two reasons. The hot gases are forced to flow through a smaller opening, thus increasing their velocity. If you've ever used a hair dryer, you can understand how the increased velocity speeds up the heating and drying process. The other reason is to concentrate the aggregate veiling in a smaller area to increase density and to increase the number of times it falls through the hot gas. So the combination of extra velocity gas working its way through a denser veil of material results in forced convection heat transfer. Looking at a single cross-section of the drum, we might see what appears to be voids where the hot gas could pass through unrestricted. But two things prevent this from happening. Flights are staggered to provide a dense curtain of material, and baffles are used to keep gas away from the shell and into the dense veil. This section of the drum is where the temperature of the water-bound aggregate passes the boiling point, and moisture is converted to steam. This phase of the drying process consumes more of the burner's energy than all other steps combined. Moving downstream, we come to the area where recycled material can be introduced. At this point, the virgin material has already been superheated. So, conductive heat transfer to the rat begins immediately, as spiral flights commingle the materials in the bottom of the drum. Full veiling is resumed to take advantage of the powerful forced convection heat that is still present. The expanded end section of the drum forms a low-profile mixing area for the introduction of asphaltic cement and keeps it out of the flow of hot gas. In this oversized mixing zone, reverse angle flights tumble the mixture of aggregate in the bottom of the drum, blending in the new liquid. The large chamber formed by the expanded rear section acts like an extension of the knockout box, dramatically slowing the gas velocity and allowing the heavier airborne particles to settle to the bottom and back into the mix. The result of these technically advanced features is a thoroughly blended quality hot mix, even at maximum production with minimum fuel consumption. CMI manufactures a complete line of Venturi mixers, from the unitized UVM500, designed for easy transport and setup, to the stationary SVM13, a 13-foot diameter plant with a production rate of over 600 tons per hour. Most of the portable drum mixers have optional, fully self-contained erection systems. They consist of hydraulic jack cylinders permanently mounted to the mainframe, a power unit with engine and hydraulic pump, and large blocking beams on all legs. The finished hot mix is carried to the top of the silo by a drag conveyor. Traditionally, drag conveyors are high-maintenance items that must be repaired or replaced from time to time. CMI combats wear in a number of ways. The floor is lined with extremely durable ceramic tiles. The roller chain is super heavy-duty, specially designed for high capacity and low wear. Flights are made of abrasion-resistant steel. A shore-drop bypass discharge gate is positioned for loading mix directly into trucks. This is particularly useful for small runs of specialized mix. When 2 or more silos are used, they can be arranged to fit the available space and plant configuration. If 6 are needed, this arrangement is recommended because it takes a minimum amount of room and has excellent material handling characteristics. This producer kept his 3 older silos and added 3 new ones when converting from a batch plant to a new Venturi mixer plant. CMI's Uniflow storage silo is unique. It virtually eliminates the greatest problem of conventional storage silos, segregation of material. And it does it in a very imaginative way. By using large rectangular discharge openings and steep walls on the cones, the material mass flows in both the batcher and the bottom of the silo. By eliminating coned piles and rat holing, the quality of the mix is maintained. Temperature of the hot mix is safeguarded with extra heavy-duty insulation on all surfaces. Electric heat or circulating hot oil is used to heat the cone, the discharge gates, and also the floor of the drag conveyor. For long-term storage, the silo is sealed, top and bottom, with CMI's patented Surelock seals. Oxygen is removed with CMI's exclusive Inert Gas System. Inert gas is heavier than oxygen, so it settles over the asphalt to form an internal blanket. This substantially retards oxidation of the AC and permits storage of the hot mix for days, a week, or possibly even longer. If long-term storage silos are not needed, CMI can provide both stationary and portable surge silos in a full range of sizes. For maximum portability and flexibility, self-erecting silos are available in single or double bin configurations. In either case, full running gear is standard, and setup is fast and easy, using the internal hydraulic system. In the double bin model, the slug feeder forms a pendulum that can swing to either silo. Every part of a CMI Venturi mixer plant is the most reliable and most efficient that current technology allows. Hot liquid asphaltic cement is heated and stored in the bitumetherm tank. It's heated by a high-efficiency direct-fired burner. Liquid AC is controlled by an innovative metering system called Uniflow. It's extremely reliable because it has only 3 moving parts. A variable frequency motor is used to control speed, and a mass flow meter is used to verify accuracy to within 0.3%. Variable frequency drive motors are also used on aggregate bend conveyors and are optional for fan and drum drive. These motors are watt efficient and offer a noticeable savings on electric consumption. CMI's Energy Control Center offers a convenient way to carry and set up multiple units on a single frame. Any number of configurations are available in highly portable models. The frame usually carries control house, motor control center, and main generator. An 8,000-gallon fuel tank can be installed in place of the generator, and space is available for a smaller night generator. By placing several units on the same frame, a minimum number of loads and related interconnecting components are needed. Quick Connect type plug-ins reduce setup time and allow for plant expansion at any time. The control house can be removed and positioned wherever it needs to be for maximum efficiency. It provides an excellent working environment with insulated walls and ceiling, central heating and air conditioning, and panoramic visibility. One of the highlights of a Venturi mixer asphalt plant is the Impulse computer control system. It will set the standards for years to come. Impulse features an IBM-type computer with hard drive and color monitor for fully automatic or semi-automatic operation, and a simplified control panel for manual backup. The screen shows an overview of the entire plant. All units have readouts for appropriate volumes, flow rates, and temperatures. 20 mix designs or more can be stored in memory, and any 3 of these can be entered into a production stack. A product demand line allows the operator to interrupt the active mix, produce any amount of special mix, then return to the active mix where it left off, all automatically without interrupting production. The Plant Diagnostics feature recognizes when a problem arises, tells the operator what the problem is, and suggests the probable causes. The Datalogger feature continually stores all plant operating information on the hard disk along with dates and times. Any part of this information can be recalled and analyzed at any time. It can be shown on the screen or printed out for a hard copy record. The simulation mode offers a complete operating experience without actually running the plant. It's a perfect environment for personnel training or troubleshooting. The programmable controller is the interface between the computer and plant. It converts computer signals into mechanical motion and physical readings back into computer data. Another function of the Impulse system is to automatically control the burner to maintain complete fuel combustion regardless of production level. Total combustion is not only more economical, but produces cleaner emission standards. Environmental issues are of prime concern to everyone. In a CMI plant, the clean air process begins at the expanded end of the drum, an extra large knockout box. Much of the particulate matter settles back into the mix. The small amount that's left flows with hot gases into the roto-air baghouse. The roto-air system eliminates most of the problems associated with jet pulse or reverse air baghouses by eliminating the moving parts that cause the problems. Roto-air uses a draft system in which cleaning air is distributed through a mechanical rotor. This very simple and reliable mechanism is all that's required to perform a continuous and effective cleaning operation. Although this type of air filtration unit is new in North America, it is well established throughout Europe and was developed in Norway. CMI is licensed to manufacture it in the United States under the trade name of Roto-Air. Today's asphalt producer needs the most efficient, most reliable, and most environmentally acceptable hot mix plant he can find. and he needs a progressive, innovative manufacturer that will stand behind his product and keep it tuned to the marketplace. Year after year, CMI Venturi mixers prove to be the most reliable and most sought-after asphalt plants. This Venturi mixer plant in Newberry Springs, California, was issued a permit to produce 550 tons per hour for 10 hours a day using 70% virgin and 30% recycled material. This is the highest production permitted in Southern California in over 10 years since the Clean Air Act came into effect. Jim Lehman, inspector for the San Bernardino County Air Quality Board, issued the permit and then made a very powerful statement. He said, "This is the cleanest operating asphalt plant I have seen in my 20 years of emissions testing experience." CMI has also earned a reputation for the best customer support in the industry. When an asphalt producer is ready to upgrade his current hot mix plant, or when he's ready to expand with an all-new plant, he wants the highest production capacity, the lowest cost per ton of finished mix, and the cleanest operation. This leaves only one decision to make: which size CMI Venturi mixer to choose.